Okay, we're now going to look at some Pythagoras in 3 dimensions. Okay, and to explore it, we're going to look at a couple of cuboid situations. So let's say we had a cuboid like so. Okay, so we're told that that length there is 3, that length there is 4, and that length there is 12. Now the objective exercise then is we need to find the diagonal of the cuboid, but it's a space diagonal. So the space diagonal begins at the bottom left and ends up at the top right hand corner of the cuboid. Now it's called a space diagonal because it doesn't only travel through a distance, but it travels through space, so it goes from the front to the back of the cuboid. Now when looking at Pythagoras, we need to look at a right angle triangle that works its way from the front to the back of the cuboid. So that's the one that we're going to try to get as much information from as possible. Okay, so we remember that from Pythagoras, to find the third side, we need 2 sides to get going. Well, we've got that side, which is 12. We don't yet have this side here. Okay, but we can definitely get it by using Pythagoras. First of all, using this 3 and 4, so I'm going to call that y, and that's going to be y squared equals 3 squared plus 4 squared. That'll be y squared equals 9 plus 16, and y squared is equal to 25. Y is the square root of 25, and y is equal to 5. So we now know that that length is 5. Now what we can do now is use Pythagoras a second time to work out x. But this time we're going to use the 5 and the 12. Okay, so that's going to be x squared equals 5 squared plus 12 squared. X squared equals 25 plus 144. X squared equals 169. X equals the square root of 169, and x is equal to 13. Final answer. Okay, let's try an example 2. Okay, this time we've got another cuboid. And we're told that this length is 9, this length is 12, and that this length is 36. And again, we're looking for the space diagonal from the front to the back here, which we're going to call T. Okay, so let's hone in on the right angle triangle that we really need to focus on, which is this one that I'm marking with the highlighter. Now, we've got the 36, but we need to find this length. So again, we can do Pythagoras. First of all, down here, I'll call that G. G equals 9 squared plus 12 squared. G squared equals 81 plus 144. G squared equals 225. G is equal to the square root of 225, and G is equal to 15. I can do Pythagoras again, and it's going to be T squared equals 36 squared plus 15 squared, and T squared equals, I'm going to use the calculator now for 36 squared. That would be reasonable. 1296 plus 225 for 15 squared. Add them together to get 1521. We'll then take the square root of 1521, and that is equal to 39. Final answer.